So I just want to illustrate how to use Excel as a solver for linear programming problems, and it'll also do some basic sensitivity calculations for you. So I want to illustrate how to do that. Go back to our lumber problem. And the cells I have here highlighted in green are just the ones you need for plugging into the solver. So that's why I've highlighted them. So in general, whatever your problem is, you're going to have some variables. There could be 2, 3, 4, or 5, but just make columns for them. So we have our finished grade and construction grade lumber. Below those, we're going to put our decided values, our decision. Remember from the simplex method, when we first start, our initial tableau assigns values of 0 to all of our decision variables. So that's what we do here. So we're just initiating them as both as 0. And then our constraints give us our inequalities. So we call those our resources. So again, the rows of our constraints, we have, say, if we have x as the finished grade and y as the construction grade, we have 2x plus 5y is less than or equal to 8. And we have 2x plus 3y is less than or equal to 15. And our objective function was profit to maximize profit, which was 120x plus 100y. And again, initially, it's 0. Again, putting these inequalities here just for reference. We don't actually need these for the problem, for the solver, but we just want to make sure that we organize our constraints in a way that will allow us to use the solver without making a mistake. In general, you could have 20 different inequalities. Some of them could be less than or equal to, some of them could be greater than or equal to, and some of them could be equations, as we've seen. So if you organize them into those 3 types, when you use a solver, you can do all of one type, enter all of one type, and then enter all of a second type, and then enter all of a third type, because you'll be given an option to choose what kind of inequality it is. Is it less than or equal to? Is it greater than or equal to? Or is it an equal equation? So once you have your model, as we do here, we're just initiating the variables as 0. We have the right-hand side of our constraints given to us. We have the numbers inside of our constraints given to us. And we have our objective function values given to us. All we have to do at this point is construct these left-hand side of our constraints for the solver and a formula for our solution. So again, what is our objective function's value? It's the 120 times whatever the value of the finished grade is, plus 100 times the value of whatever the construction grade is. So there's a built-in function in Excel called sum product, which is basically a mathematical dot product. So you think of this 120 and 100 as a vector with 2 coordinates, and you think of the 0 as a vector with 2 coordinates. The dot product is just adding the product of the first coordinates plus the product of the second coordinates. So in Excel, sum product, you just highlight the first row that you want to match the numbers up, and then a comma, and then the second row. And it will perform that calculation, 120 times 0 plus 100 times 0. We do the same thing for the left side of our constraints. The solver only wants 2 cells. It doesn't want the whole array of cells. So we just need to know how much resource is actually being used, depending on the decision that we're currently using. So again, we use the sum product because we want 2x plus 5y, which is just 2 times 0 plus 5 times 0 at this point. So that's why we have 0. So if you're just putting number 0 here and number 0 here, the solver will not work. You have to enter these formulas using sum product for these 3 cells. These 2 are you're just assigning 0, and these 2 you're assigning the values given by the problem. So once we have this all set up, we can use the solver. Now, depending on if you're using a Mac or Windows, if you're on campus, you will need to go into the Data tab. Again, yours might look different than mine depending on the version you're using. But you'll possibly see something Data Analysis and Solver. These are not automatically loaded. So if you don't see these, you'll have to go in and add them in. There are add-ins that come with the software. You just have to go and load them. If you're having trouble, just Google, how do I load the solver in Excel? And you'll see someone will show you how to do it. If you do that and can't figure it out, then contact me and I'll help you. But for once we have this loaded, we just take our solver and then let me clear out all these cells just so we can show you from the beginning what we have to do. So the objective is just the cell where the value of the objective function is. But remember that is a formula that we need to have that being computed as a formula with a sum product function. This is a maximization problem. You're maximizing profit. And then the variable cells. These are our decisions. So we just need to highlight the variable values. Again, currently they're 0. Oh, it put it in the wrong cell. So let me start over. Objective function. All right. Now I want to add the constraints. Now in this case, this simple problem, we have 2 constraints and they're all of the same type. So you can do, if you organize your constraints all in blocks, like all your less than or equal to ones, and then all your equal to ones, and then all your greater than or equal to ones if you're doing a more complicated problem, then you just need to add 3 constraints. In this case, we just have to add 1. It appears as 2 constraints, but we do it all in 1 because they're both of the same type, less than or equal to. So when I add the constraint, again, notice we have less than or equal to. I don't want that cell. I'm just clicking it to illustrate that we want less than or equal to. So we want to make sure we have the choice, less than or equal to. And then we highlight all these green cells for the constraints that we've used by constructing the formula using the sum product function. So for the cell reference here, I just highlight all of those. If you had 20 constraints of the less than or equal to type, you would highlight 20 cells. And then on the other side of the inequality is what we were given in the problem, the amount of resources that were made available. That's the only we have to add, so we're basically done. We're using the simplex method, and we hit solve. It's going to give you a question for some options. We want answer, and we want sensitivity analysis. Now, these other options, I prefer to restore original values so you still have the original problem in one of your tabs. It doesn't overwrite it. And we want outline reports. And then it'll produce basically everything we need. So we have our problem here, original problem. Now we have the answer report. You can see what kind of information it's giving us. Again, our objective total, that was our objective function, 480, we can see is our optimal value. Our finished grade number, final value 4. Construction grade number, final value 0. So that's our decision, 4, 0. And we can see for our resources, the rough saw hours were used. That's why labeling is important, because you'll actually get these labeled in the report. So slack of 0, status binding, that means we used all of those resources. The plain hours, because slack is 7, we didn't use all of those resources, so they call that non-binding. Now the sensitivity report will tell us about our objective function coefficients, just like we did graphically. So for, again, finished grade lumber, they're re-giving us the value for the objective function coefficient for that was $120 per 1,000 board feet finished grade lumber. And there's an allowable increase and allowable decrease. Now these are the numbers that we did graphically by setting the allowable change of the other constraint equal to 0. Right, if the other coefficient equal to 0. So when this Excel does this, if you have a 20 variable problem, these are the numbers that if all other numbers from the objective function were set to 0, or their change was set to 0, then it would be the allowable change of that one coefficient. All right, so the number 120, this is 1 times 10 to the 30th power, so this is the computer's way of saying infinity because it can't really say anything more. So basically increasing the profit per unit of finished grade board feet won't change our choice to produce only finished grade board feet. I mean, that makes sense. If your decision is optimal to make only one kind of product and you're able to actually sell that product for more and more money, then you would keep doing that. But there's also allowable decrease of 80, meaning that the company's not going to decide to produce or any construction grade lumber until the profit that they can get for the finished grade drops from 120 down to 40. It drops by 80. At that point, it becomes a better decision to start making construction grade lumber. And then for the construction grade lumber, same idea. Here the value is 0. The coefficient was 100 in our objective function. Again, if it increases by 200, then it would be a good idea to start producing construction grade because its profit is much higher and more optimal to do that. But it can decrease as much as we want. Again, we're already not using or not producing construction grade lumber, so if its profit decreases, well, we're not going to change our mind. All right, so use your common sense with these kind of things. It's not button pushing. I mean, there's a lot of button pushing to get this. It's not a big deal. But to actually interpret what these numbers are, use some common sense.